Madison, Wisconsin. So
are expecting a
tell me to get on the
full
plane.
flight today.
I gotta get on the plane, but until then, I am all yours. And
Full flights.
I want to tell you guys
We could invite
about a
you
math problem I spent a long
to
time thinking about. Actually, to be honest, I spent about 20 years thinking about it. I've not
process and
constantly, like not nonstop, but like on and off. And depending on how much time we have, I'll tell you about how I ended up making a little bit of progress on it. But the question I want to start with is, do you guys all know the card game Set, or how many of you know it? You can give me a little hands up on your Zoom, or if you actually have your camera on, you can put your actual hand up, just so I know. I see some thumbs up. That's also acceptable. Okay, so let me remind you, if you haven't seen it, Set is a card game that has these kind of not normal cards, but these kind of funny cards where they might look. Here's an example of how a card might look. And each card has 4 attributes. It has a color, which could be red, green, or purple. So I guess the one I drew here was green. It has a shape, and some of the cards have ovals, some of them have diamonds, and this one has a shape which I can't draw it very well, and people have different names for it. So I some people call it the peanut. I like to call it the swiggle. It has a fill pattern, so the thing can be empty, it can be striped like the ones I drew, or it can be completely filled in. And finally, there's a number. So there's either 1, 2, or 3. And so every combination of these attributes can be found on a card. If you want to find a card that has like 3 filled in red diamonds, you can find one. There's all the cards are different. There's exactly one card that. So I guess the first pretty easy math question about this game is just how many cards there are. And in fact, somebody was literally playing Set 5 minutes ago. Okay, from Ezra. Because time is limited, I would just tell you that, well, I mean, each of these attributes can take any of 3 values, and there's 4 attributes. And so the number of cards is 3 times 3 times 3 times 3, or 81. So it's a little bit fatter than a regular deck. And the cool thing about this game is that it has only one rule. This is it. Ready? It's a little bit of a mouthful to say. Rule: a collection of 3 cards is a set. And now this is a little confusing. We're going to talk about math today, and math, many of you know, the word set has another meaning. So, set, GM, a set in the sense of this card game. If for each attribute, the 3 cards are either all the same.
Good evening, ladies and gentlemen, and welcome to United Airlines.
All different. Okay, so I know Ezra was just playing this game. He knows this very well. I think we can all agree that if somebody told you this rule, I don't know how many of you remember the first time you saw this game. It looks a little weird. You're like, that's a strange rule. Why that rule? And yet, I think you also find, or at least most people find, that this game is extremely playable. Like, this sort of seems like it would be like a hard thing to think about, but your mind is actually like really good at locating these sets. And maybe I should say that actual gameplay of this game is very simple. There's a bunch of cards out, and every time you see 3 cards that make a set, you yell set and you grab the cards. And then whoever, and then you as needed, if you sort of nobody can see any sets on the board, you lay out 3 more cards and you keep on going and keep on going. And whoever ends up with the most cards wins. So it's basically a game about being good at recognizing these sets. And this is something that you can actually get pretty good at it. In fact, my origin story of thinking about this problem is that
if you don't have
about 20 years ago,
We are
utterly
working on
crushed
those
in this
now,
game by the
and we will
8-year-old child
provide
of one of my
an
colleagues. I
update
determined I was
shortly.
going to prove a theorem about this game. So I'm like, this kid is much better than me at that playing the game, but maybe I'm hopefully better at proving theorems than an 8-year-old. And so that was what I set out to do, and eventually did. So I said in gameplay, it can get a little tense actually, because when there's a bunch of cards out on the table, you kind of think, oh man, there's gotta be a set in there. There's so many cards out there. There's gotta be a set. And the more cards there are, the more strongly you feel that way.
For those of you who would like
And
to
very frustrating when
enjoy
you can't
our
see it.
personal
And so
device
one natural question
entertainment
is,
during the flight,
how many
please
cards
download or update
are
the
out there
United app on your
to
device
make it so that
before
actually that
boarding the
information has
aircraft.
to be correct, it's provably
Unfortunately,
correct, but there
you
must be
can't
a set. So in other
download
words,
the
here's a
app
question.
during the flight.
What is the smallest n
For
such
those
that
of you who would like to enjoy
any-
our personal
well,
device
capital,
entertainment
any
during
n
the flight, please download
cards
or update the United app on your device before
contain
boarding the aircraft. Unfortunately, you cannot download.
I don't know, maybe that's what
the
Neil
app
means when he says
during
the task can be
flight.
impossible at times, right? So if it's certainly possible to have some cards out and there's no set there, but obviously if you have all 81 cards, there's a set out there. So somewhere in between, there's some threshold value where once you have that many, you know there's a set. Or another way to phrase this, which is maybe a more common phrasing, is, or what is the largest collection of cards without a set? And so what I want to do before I sort of tell you the answer to this question and some related questions is try to answer the question of why this game actually feels very natural to the mind to play, even though the rule as written looks very strange. So let me make a following observation, which I think most players of this game play quickly, that if I have two cards out there, I'm going to sort of draw some cards. Let's see, so we'll pick a green one, and because I'm on the iPad, not a blackboard, I actually can change my, oh, that's supposed to be red. All right, can we pretend it's red? Let's say you have these two cards out there. And you're hoping, oh, maybe I can find a set with these two. And indeed you can, but it's actually pretty specific, because if this card is green and this card is red, then the three colors have to be all different. They can't be all the same, because I already have two that are different. There's no way around it. This card has to be purple. What's the card? The numbers can't be all the same, because I already have two numbers that are different. And so the third number must be 3.
Any spare.
The shapes, I have two different shapes. So the third shape must be different too. So it must be a squiggle, that's fluff. So I know I have 3 squiggles, but what's more, the 2 fill patterns are the same. They're both empty. And that means the third one also has to be empty, because if it were either filled or shaded, then there would be 2 of one kind of fill pattern and 1 of the other, which is not allowed. So there's exactly one way. There's not like a bunch of different sets which each contain these 2 cards. There's only one. So let me write that. That's sort of something that is a pretty familiar fact that you pick up as you play. So first theorem of set, there is a unique set containing any 2 distinct cards. Not a very hard theorem to prove or to satisfy yourself is true. And what I want to emphasize is that already in this theorem, and I carefully phrased it in a meaning in a way that's meant to be evocative. Does this look like a theorem you know? Anybody? I said there's a bunch of people. I love that there's so many people on this chat, so I'm curious. I tried to write this in a way that it would look a little bit familiar, and I wonder if people have any. Does this remind you of anything?
By the way, I do have a question. Why do the cards have to be distinct? Why do the two cards have to be distinct? If they're the same, then the other card could just be the. Oh, right. They have to be distinct in the game.
Yeah, so there would be if I had two copies of the same card. I mean physically I don't in the deck, but if I sort of happened to own two decks and I had two copies of the same card, I guess there would be a lot of well, maybe a way to say it is that if you sort of applied the rule, then for each attribute, two would be the same. So if you were allowed to have multiple cards, if you had two copies of the same card, the third card would have to be a third copy of that same card. So I guess actually you could argue that in some degenerate sense, the theorem would be true if I were allowed to have multiple copies.
Morning groups 1 through 4.
That's a great point. I didn't see that one side.
And one personal item on board.
Okay, but
That received.
okay, is anybody seasonally familiar about this statement?
2.
Okay, so I guess what I would
We are now going to start
interesting.
pre-boarding for United
I'm not going to
Airlines
pigeonhole, so
flight 23,
suggested
28 to Madison.
suggested that,
If
but
you are in groups 3, 4, or 5,
but
please make yourself comfortable
I
until your
tend to think of
group
this game
number
as
is
a game about
called.
geometry.
Our Chase
And I didn't think of
United
this
card
theorem
members
as a
that
theorem about
receive
geometry. So let me
priority
just
boarding
change it,
benefits
then I'm going to change
will be
the color
boarding
again.
in group 2.
If I think of the cards as points, and I think of sets as lines, this looks like a real theorem, right? A theorem you guys know about geometry. And indeed, this is a really good way of thinking about this game, that this game forms what we would call a finite geometry in which sets are lines. And that's good because I don't like writing set TM all the time. It's very tiring. I'd rather write lines. You should think of what's happening in this game is you have a bunch of points. And every time you see 3 points that lie on a line, you see 3 points that are collinear, you grab them. And I think that's one reason why this game feels kind of natural to play. Now, if we had more time together, it's sort of more leisurely exposition, but I do want to tell you guys that this is not just a metaphor. We can actually make this. We're going to kind of do a world run tour and use like all different kinds of math. So we're going to do a little bit of algebra now. Oops, sorry. So this is not just a metaphor. We can think of a card.
Active
does somebody want to say something? I heard a voice.
Traveling to Nashville are welcome to free board, and we thank you for your service. As a reminder,
With
customers
coordinates, how
in
can I
boarding
do
groups
that?
1
Well,
through 4
I'm going to
may
scroll
bring
back to this
1
little attribute,
carry-on
and I'm
bag
going to say
and 1 personal
Okay,
item
I'm gonna
sent
encode
on board.
each of these columns as a number 1, 2, 0.
Global
Okay, so if we look at
Services
this card,
Customs
2
Craft
striped
Food,
green squiggles.
Nashville.
Okay, so green represents,
Board.
is represented by 2. A squiggle is represented by 0. Striped is represented by 2, and the number, which is 2, is also represented by 2. So this is the point. I'm going to give a coordinate and say the coordinates are 2, 0, 2, 2.
To Nashville. Are welcome to pre-board.
With coordinates X, Y, Z, W, representing the 4 attributes and taking values in 1, 2, or actually, I'm going to say I'm going to
Here,
use the numbers
customers traveling to
0, 1,
Nashville.
2, and I already see someone sort of
Pre-board.
jumped at this in the a couple people in the chat. I could think of these things as numbers, but I want to do something like a little bit cooler, and you'll see why in a moment. I want to think of these as numbers modulo 3. What's the difference? Like numbers modulo 3 or 0, 1, and 2. So like, who cares whether I think of them as like honest numbers or numbers mod 3? Well, do you guys know
United Airlines flight 2001
how
1 traveling
So this is
to
this is an algebra
Nashville.
question. I wonder if some of you might have encountered it.
Disabilities.
Do you know how to find the
traveling
midpoint
to
between two
Madison.
vectors?
Are welcome to Freeboard. United Airlines Flight 2001, Group 2, active military.
Let's write them in x1, x2, x3, x4,
Are welcome
y1,
aboard.
y2,
And we thank you for your service.
y3, y4. Well, yeah, average. I like what Samar says is exactly right. I would average each coordinate. So midpoint is 1/2 x1 plus y1, and then same thing, 1/2
Global services
x4 plus
customers
y4.
traveling to.
All right, well, let's try and do
Madison
this
Are welcome
with these
to
cards.
Freeboard.
Let's see, what was my other card? I had 2, 0, 2, 2, and I'm just going to make up some other card. Let's say I have a card that was like 0, 1,
Children
2, 2.
and under traveling to
What would the midpoint be?
Madison. Are
Okay,
welcome
2
to
plus
Freeboard.
0 is 2. Half of that is 1. 0 plus 1 is 1. Now we got to figure out what is 1/2. What is 1/2
For those passengers on.
mod 3? If you think of this in the way of like I'm reducing this number mod 3, it's kind of confusing. How do you reduce 0.5 mod 3? But a better way to think of it is that 1 has a lot of other names modulo 3, right? 1 is the same number as 4.
United Airlines Flight.
And so this is 2.
2001, Group 3.
Now you might say like, well, why did I pick,
Nashville.
why did I call 1 4? 1 is 4 mod 3, but 1 is also, I don't know, -5 mod, or sorry, it's negative. It's also -2 mod 3. So why did I say 2 instead of -1? Well, the answer is 2 and -1 are the same numbers. Those are different names with the same thing. So half of 1 is 2, and here we got 2. Now the average of 2 and 2 is just 2 again. And what I want you to see is that something very cool happens. This averaging operation exactly says that if these two numbers are different, their average is the third number we didn't yet use. Whereas if these two numbers are the same, just as you might expect, their average is another copy of that third number. So this crazy rule of set, this very weird looking rule, is actually exactly the rule for averaging mod 3. And it exactly tells us that indeed, in this algebraic sense,
Traveling to
the third point
is now
welcome
to board.
is on the
Premier
line.
one-day customers traveling to
Okay.
Madison are welcome to
So-
Freeboard.
I hope I've made the case that that this is a problem about geometry, that we're asking the question about some kind of geometry over the mod 3 numbers, and we're trying to find large sets of points with no 3 collinears. But how do we actually do that? This is not so obvious.
Please come to us at the podium. So once again, passenger student row 21, welcome to board at this time. Please do not utilize the gate reader.
Okay. Oh, why do 2 different numbers always produce a third different number? Let's try. Let's do 1 plus 2 over. Oh, sorry, over 2. Well, 1 plus 2 is 3, and 3 is 0.
Traveling to
Equals 0.
Madison
Okay, 0 plus
is
1 over 2 we already did.
to board
Uh,
Blue Lane.
We found that 1 over 2 is
One.
2 because 1 is 4, and finally 0 plus 2 over 2 is 2 over 2, which is 1. So one way to see it is just that there's so few numbers that we can just check exhaustively. So Ezra asks, there's also a condition where no set of 4 points is collinear, right? Well, okay, that's a great question.
Please,
I'm going to
when you see your body best, let the door
put
close
as a
first.
challenge exercise. Exercise in this geometry, no 4
United Airlines
points
Flight 2328,
ever
Group 2, traveling to Madison
collinear
is now welcome to board to
line.
the Green Lane.
contains only 3 points. All right, guys, it looks like there unfortunately, it looks like they're putting me on. So I think I'm gonna need to depart for now, so that I can like put all the stuff away. before
Measures
they
to
close.
ensure everyone's health and safety. We are encouraging all of our customers to scan their own boarding passes. When
So
you
I guess the
approach the
takeaway
boarding
here
agent, please have your
is-
mobile boarding pass.
I don't want to
or
leave you
your
without giving you the
paper
punchline, telling you
boarding
we can do
pass
this question.
available.
So
When it is your turn to board,
so answer to the
we
question
ask that you
is
scan the barcode on the
there is
scanner. As always,
set
we are available to
of
provide
20 cards,
assistance during the boarding process.
containing no set, and it's a very fun exercise to try to come up with it. It's not so easy actually, and you would never happen to come up with it while you were playing, but there is one. But let me close by saying, what is the question mathematician would ask about this, and the question that I ended up working on. So the real question is
United Airlines
D
Flight 23,
dimensional set
28, Group 3, traveling
is
to Madison,
the
is
largest
now welcome to
set
board to the
free
Green Lane United
collection.
Airlines
In other words,
Flight
we did the case D equals 4,
2001.
but if but you could ask an easier question to be smaller or a harder question to be bigger. And the thing I worked on was, well, not quite to answer this question, but to give an upper bound that was the best known. Guys, this is fun to talk about, and I wish I had longer, but they are sort of boarding the last group, so I got to get on this plane. Great to see you guys. My email is easy to find. Simon has it. If you have more questions about this, because I didn't get to stay the whole time today because I got to get on this plane, I will happily talk to you about them. It's great to see you all on Zoom, but I'm going to sign off. Thank you so much for spending this this time with me.
Thanks, and have a good flight.
Thanks,
Thank
Simon.
you.
Sorry for being in a rush today.